Okay, so one of the attributes of a powerful mathematician is the ability to find an appropriate model for a given situation. By knowing the graphs of basic functions, we can quickly connect visual information with equations and classify functions appropriately. In addition, some equations and graphs work only for select values of the independent and dependent variable. So for example, we can't square a real number and get a negative answer. We can't divide by 0. We can't take the reciprocal of 0. And many situations in real life have constraints that limit the domain and range. Just like yesterday with our open box, you couldn't cut, 20 centimeters out of the box, or you couldn't get a negative volume. So there's real life constraints as well. So I'm hoping that a lot of these functions are familiar to you, but at least we're going to name them again and see their equations, because we're trying to catch up on all things Algebra 2 before we move on into new study. So the linear function, your book also calls the identity function, and it's y equals x. So like slope y equals mx plus b. So to graph the parent function of a line, the y-intercept is 0 and the slope is 1 for a parent function of a line. So if I start at 0, going through 0, 0, I would just go up 1 over 1 and down 1 over 1. So just, a line. Then I could change the slope and y-intercept if I wanted to, but can you see that okay? There we go, that's better. So just graphing a line through the origin. It might be, if you want to remember y equals mx plus b, that's a good thing to know, slope-intercept form. Does anyone know the domain and range of this line? What would you say the domain and range are? Are there any limitations? Can x be positive? Can it be negative? Could it be a fraction? So we just say that the domain is all real numbers, that kind of capital bold-faced R. If you want to write negative infinity to infinity, that's fine. And then the range is also all real numbers. Is that a familiar symbol to you? Because you could write out the words all real numbers if you prefer. So that's just a linear function. Degree is 1. We're going to talk about degree this unit. And then right next to it, I put a constant function. I probably should have put these in a different order, but constant is just y equaling a number. So like y equals 3 is a constant function, and it's just a horizontal line. So no matter what x is, a constant function is always equal to that a value. So in this case, y is always equal to 3. So its domain is all real numbers, but its range is just the number 3. It can't be anything else. So that's called a constant function. Stays the same no matter what you plug in. I hope you're really familiar with a quadratic function. That should have been a big focus of Algebra 2. We learned how to graph and factor them, and hopefully it's like riding a bike. Those skills will come back. Your book calls this a square function, so quadratic or square. Y equals x squared is that parent function. Do you remember the name of the graph? It starts with a P. Parabola. That's a great vocab word from Algebra 2. So it's a parabola. And do you remember the key points? So the key points, where's the vertex? Vertex is another good word for parabola, but 0, 0, right? What happens when you square 1? 1 squared is 1. What about 2 squared? 2 times 2? 4. What about 3 squared? 3 times 3? 9. So a parabola goes 1, 1 on either side, and then it goes 2, 4 on either side, and then it goes 3, 9 on either side. Does that, I hope, ring a bell from, it was drilled into you in Algebra 2, I hope. So you need to know the key points of the parent function parabola, 1, 1, 2, 4, and 3, 9. It has symmetry. That's another good vocabulary word, right? It's symmetric, it has an axis of symmetry. So whatever x value is plugging in, you're squaring it to get the y value. It can never be negative, right? Because you're squaring, so you're always going to get a positive output, unless there's a transformation. We're going to talk about transformations today too. All right. What's the domain of this function? So when I skim my x values, can I plug in a negative number? Can I plug in a fraction? Can I plug in a positive number for x? Sure, I can plug in any number I want for x. So my domain is all real numbers, but the range, the output, is always going to be positive, right? All the y values are above the x-axis. So my range is that y has to be greater than or equal to 0. I'm never going to get a negative y value for the parent function. Does that ring a bell? I hope. So there's a lot of information packed on this. It's kind of a review, but it's kind of your library of functions here. All right, the square root function. I want you to think about a table of values because this is probably not a familiar function to you. So let's talk about some important values. How about -1, 0, 1, 4, and 9? I'm picking some specific x values on purpose. Can I take the square root of -1? Can I plug -1 in? What happens? So if you actually take the square root of -1, error, non-real answer. Do you remember complex numbers a little bit, maybe? So I cannot do it, right? So this is undefined at -1. What if I take the square root of 0? Can I take the square root of 0? The square root of 0 is 0 because 0 times 0 is itself. So 0, 0. Can I take the square root of 1? That's a perfect square, right? The square root of 1 is 1 because 1 times 1 is itself. Why did I skip to 4? Could I take the square root of 2? What's the square root of 2? Anyone know? It's about 1.4 because 1.4 times 1.4 is about 2, right? A square root just says what number times itself will get you back to where you want to be. I could take the square root of 3. The square root of 3 is about 1.7. Why did I pick 4 as my next key point? It's the next perfect square, right? So the square root of 4 is 2. So I just picked a perfect square there. And then I jumped up to 9, the next perfect square, because the square root of 9 is 3. So these are what I say are the key points for the square root function. And it's basically the inverse of the quadratic function, right? This was 1, 1, 2, 4, 3, 9. This is 1, 1, 4, 2, 9, 3. So 0, 0, 1, 1, 4, 2, and 9, 3 is half of a sideways parabola. That's the square root function. That one you might never have seen before. So that's why I wanted to tell you where the points are coming from. I want you to recognize that that's the square root function. We're going to be graphing and transforming that function. So you may need to memorize that parent function if you've never seen it before. This has a very specific domain and range. So as I skim through the x-axis, what was allowed and what was not allowed? Could I plug in -1? No. So my domain is that x has to be greater than or equal to 0. What about my range? Did I get any negative values for y? So y also comes out as greater than or equal to 0. So I think that's the first function that might be unfamiliar to you, and it's probably unfamiliar to all of you. Quadratic, you're going to have to bring that back because we spent a lot of time in Algebra 2. All right, so those 4 are very different shapes. So you're going to have to identify functions based on just looking at a collection of points. Oh, that's quadratic. Oh, that's linear, right? Those vocab terms need to be kind of fresh in your brain. All right, here is one that I put on the parent function list, but I'm not going to really be assessing you on it this unit because we're going to spend a whole unit on rational functions. But it's called the reciprocal function. I'd like you to just kind of sketch it for now. If I plugged in 0, would that be a problem? So if I plug in 0 for x, is that going to be a problem? And why? Can you divide by 0? What's 1 divided by 0 on a calculator? Can't do it because you can't divide by 0. So I can't plug in 0. What happens if I plug in 1? What's 1 divided by 1? 1. How about we plug in 2? What's 1 divided by 2? A half. What's 1 divided by 3? A third. So this is going to get smaller and smaller and smaller. And then there's this special region of the graph. If you plug in a fraction, like if you plugged in 1/2, does anyone know what 1 divided by a half is? When dividing by a fraction, don't be shy, flip the second and multiply. You actually can multiply by 2. So 1 divided by an 8, you're actually multiplying by 8. So what's going to happen? As I divide by these fractions, the actual y value output is going to get bigger and bigger. So we're going to study rational functions, but basically it forms these two elbows, one in this positive quadrant, the other one actually forms in this negative quadrant down here, and it ends up with these asymptotes along the x and y axis. So I just wanted to plant the seed because I'm not going to be assessing you on this function in this unit, but we are going to see this one a lot. So you've got these two elbows kind of in opposite quadrants from each other, and they each have a domain that x cannot be 0 and y cannot be 0. Because you can't divide by 0, and if you already have 1 in the numerator, you're never going to get 0 as an output. So that's one of our, like, a whole unit this year. So I just wanted to at least be able to see it with all the other functions. But if that one scares you a little bit, it's not going to be on the unit 1 test, you know. Absolute value, you should hopefully remember from Algebra 2. Can someone describe the shape of that graph for me? Anyone remember? It's a letter of the alphabet. No, the parabola is the U. It's not an S. Oh, I'm so sad. What? It's a V. A flying V? Absolute value graph? Maybe? What happens when you plug in 0? What does an absolute value symbol do? It basically gives you the positive result, right? Because it's the distance you are from 0 on the number line. So like the absolute value of 7 is 7, and the absolute value of -7 is also 7. So if you plug in 0, you're at 0, 0 for your vertex. And then if you plug in any positive number, it's going to give you the same number back. So 1, 2, 3, 4 is going to give you +1, +2, +3, +4. If you plug in a negative number, it's going to give you the positive answer. So -1, 1, -2, 2, -3, 3. So it's a V-shaped graph with a slope of 1 in each direction, or a slope of +1 and then a slope of -1. Does that look familiar? I know we transformed this graph in Algebra 2. So that's a parent function. I'm kind of assuming that with a little bit of review, now that one's back in your brain. It had a domain of all real numbers, but a range that y always had to be greater than or equal to 0. Spent a lot of time on that in our transformation unit of Algebra 2. This one's like brand new to you this year. So that one's not on the Unit 1 test. This one you can expect on the Unit 1 test. We're going to spend a lot of time on exponential functions. So I wanted the parent functions, but again, not highly assessed on Unit 1. I might just ask you to recognize the shape of the graph. Exponential increasing, I'm just going to do a rough sketch for you, right? This is exponential increasing. This is exponential decreasing. So at this point, I don't even care if you have exact points in your head, just recognizing exponential increasing versus decreasing, what they look like. So that's why I'm making this kind of just look like a rough sketch of points. So I'm not going to have you graph that one by hand yet. Its domain, what do you think the domain is for this one? Can I go left and right as far as I want on the x-axis? What about up and down? Can I go up and down as far as I want? Remember, it has this asymptote that it can't go below 0. So your domain is all real numbers, y is greater than 0. In Algebra 2, you should have studied exponential functions, graphing them, I hope, talking about population growth. So we're going to spend a whole unit on exponential functions this year, but that's what they look like. This has all real numbers and also y is greater than 0 still. All right, the last two are probably new to you, but they're going to be parent graphs that you need to know, Unit 1. So the cubic and cube root function. I'm going to start with cubic because I can easily make a table of values for you. Let's do -2, -1, 0, 1, and 2. What happens when you cube a number? So when you cube a number, you multiply it by itself 3 times. So what's -2 times -2 times -2? 3 negatives. -2 times -2 times -2 gives you what? What do you think? Huh? Yeah. -2 times -2 times -2 gives you back -8. So at -2, you're at -8 on the graph. So if you forget these functions and you don't have a calculator, you're going to have to generate a table of values for yourself. All right, what's -1 cubed? -1 times -1 times -1 is what? Yep, -1, -1, 0, comma 0, because 0 cubed is 0. And then 1 cubed is +1, and 2 cubed is +8. So this is the, someone said S. To me, this is the one I think of kind of like an S-shaped graph through the origin, like a curve, cubic function. When we looked at these in polynomial world of Algebra 2, we kind of looked at them as exaggerated cubic functions. That's a cubic function. That's the parent function that hasn't been stretched or transformed. And then the cube root lays on its side, just like over here, quadratic and square root laid on a side. It's kind of the same thing over here. So for the cube root function, you want to think about the numbers that you're going to take a cube root of. Oops, not -2. -8, -1, 0, 1, and 8. So I'm picking those because I'm picking my perfect cubes, right? When I plug -8 in, the cube root of -8 is -2. Just like I took square roots of 9 and 4. So I'm picking my perfect cubes. And then, so this is the cube root of -1 is -1, 0, 0, 1, 1, and 8, 2. So it lays this on its side. So this one is also a pretty new one for you. So 0, 0, 1, 1, and -1, 8, comma 2, and -8, -2 is this kind of sideways S. So cube is growing faster and faster, and a cube root is growing slower and slower, really slow growth. So that was a lot. Those are, what, 10 functions. You know, you don't have to be able to graph these 3, reciprocal, exponential, you know, for your unit test. These I'm not going to hit on too much. Maybe I'll just hit on the equation and transforming the equation. All right, so if you look at the next page, I did not label this one as a resource. So, you know, at the end of this unit, we're just going to throw the guided practice away, or you could keep it in a separate folder at home. But this is the practice I want you to try. And you could either refer to this sheet or try to do it without. Like if this was a quiz, could you answer questions 1 through 4? So I'm going to record my answers here. So this was absolute value. The domain, I should have drawn arrows, but the absolute value graph goes forever on the x-axis. I can plug in whatever I want. But on the y-axis, I only went down to -4, and then it was everything that was above it. So y had to be greater than or equal to -4. And I think of it as, can I squish this graph horizontally? And then can I squish the graph vertically? That's how I think about it. Number 2, hopefully you could see that that's a linear function. And its domain and range is all real numbers. It's going forever on the x and the y. So all real numbers, all real numbers. And then the parent function, I hope that you were drilled with quadratics. It'd be nice if you put quadratic, not parabola, but I get where you're coming from if you wrote parabola. The domain, this, it should have arrows, but a parabola can go forever on the x-axis, but then let's see, this one starts at 4 and then is flipped upside down, so y is less than or equal to 4. Again, it's going to take some practice. We've got a few days of homework and practice and a quiz review, so by Thursday next week, we just want to have domain and range under our belts. This is a square root function. I should have drawn the arrow, but square root is half of a sideways parabola. It looks like it's starting at 0 and going to the left. So my x values are all less than or equal to 0. It looks like, did you estimate that this was 1 on the y-axis? I don't know. If you said 2, I wouldn't count you wrong, but it looks like all my y values are, what do I want to say, 1, greater than or equal to 1. It's definitely not at 0, because 0 would be way down here, right? 0, 0. So that's definitely above the x-axis, something like that.